Just want to say thanks for coming. I know you had a lot of obstacles in your way today. It's the last day. You had the party last night. It's pretty early. And so you guys have shown some tenacity in getting here and being here. So we shall hopefully reward you with some good info. And we definitely have some cool red hats. So please don't forget to pick one up on your way out. But today we're going to talk about something completely different for an Ignite conference. I guarantee you've never seen this material before at Ignite. Microservices in style with Java and MicroProfile. And my name is Brian Benz. I'm a cloud developer advocate at Microsoft. And
Cesar Saavedra. I'm an app dev evangelist with Red Hat.
And James Faulkner, also with Red Hat, app dev technology evangelist.
And welcome. So today we're going to talk about what is MicroProfile, what makes up the MicroProfile community, MicroProfile development, and then talk a little bit about Thorntail, which used to be Wildfly Swarm. And we've got some really cool demos that we put together last week when we met in San Francisco at Jenkins World. We had some fun there. And we'll talk about some next steps for you guys as well. So what is Eclipse MicroProfile? It's really an open source community. Back in 2016, I believe it was, at Java 1, there were some discussions among some luminaries in the Java world, and basically the whole idea was we've got these MicroProfiles, we've got these microservices that are being built in various different ways, and they are by nature needing to be independent or interdependent on each other. How could we make that happen? At the same time, J2EE was having some challenges with getting to market, and it was bloated. So really, this was a way to build some simple, interoperable microservices and see if we can get enough people together to make it worthwhile to have these things be able to interconnect. Have I got that right? I'm probably, perfect. Anything to add there? Okay. So it's a community of individuals, organizations, and vendors who got together, and we'll show you a little bit about some of them in a bit, and bringing those microservices, not just to the enterprise, but to consumers and the community as well. So the whole motivation behind MicroProfile was really about interoperability, being able to, there's when it started out, there's three basic parts, right? There's JSON-P, which is a way of manipulating JSON. There's JAX. JAX-RS is a way of actually managing interop between the microservices. And then there's CDI, context and dependency injection, which is a way of managing state between those applications as well, passing off information. Then some other things were added as well. But the whole point of it was to make it simple, make it easy to use, avoid people going off and doing things that might end up being impossible to connect. And I guess a short way to say that is avoid fragmentation. And then build quickly through lazy consensus, meaning everybody can use these really, really simple things to build their microservices. It's a good starting point and a place if you provide these context management, interoperability, and manipulation of JSON, at least at that basic level, you'll have some interop that you'll be able to work with other microservices with.
And just to add something, yeah. a quick comment there. So MicroProfile, just by the show of hands, how many of you guys use Java in your development daily life? Okay, good. Okay. How many of you guys use Java EE or an app server? How many of you use Node for microservices? How many of you use Spring Boot?
Everybody.
Very good. So I mean, microservice is a daily, way of doing things nowadays. Companies are moving in that direction. And MicroProfile is a community-driven open source specification for enterprise Java microservices. Now, I make stress, the stress is in the community driven because there is no single vendor that owns the specification. This is all a community of vendors, users groups, including Java users groups, as well as just individuals that participate. There you go, thank you. That participate in this community. So as you can see, there is Java, there's the London users group, there's Microsoft, of course, Oracle, Fujitsu, IBM, Liban, and you can read the rest, Red Hat, of course, there. And right now, there are 8 implementations of MicroProfile in the market. So since the specification allows you portability across any vendor implementation, that's one benefit that you get if you use MicroProfile. The next slide is the implementations. So these are the current ones that exist in the market, so you can pick whichever you want. And I'm sure there are more coming. And as Brian mentioned, MicroProfile 1.0 was announced in June of 2016 at DevNation. And the initial components of MicroProfile were 3 existing Java EE specs. And the reason that we did that is because we wanted the community to decide how the spec was going to evolve. So CDI, JSONP, and JAX-RS were the first APIs. We did not want to reinvent the wheel, right? But since then, MicroProfile 2.0, we're at MicroProfile 2.0, and as you can see, there are 12 APIs, out of which 4 are leveraged from Java EE, and the rest are MicroProfile specific APIs.
As you can see from this slide, things have been evolving. So we started with the base at the bottom, and then there's been several iterations of these. We haven't just added packages. We've added packages and then improved them to interact with the basic 3 packages at the bottom. So,
and one more comment real quick. The MicroProfile community, the processes are super light and agile. And that's why we've been able to generate, if you can see the number of releases that we put out, we're already at 2.0. Now we recently decided to go from 4 releases per year to 3. So we're shooting for February, June, and October releases. Okay. So anything else, Brian?
Yeah, no, I was just gonna, exactly. So frequent releases, that's the lazy consensus as well. So we're building things, we're iterating quickly. And then at the same time, a company like Microsoft and Red Hat and other companies, when we build services in the cloud, it's to our advantage to work with these platforms to actually develop and deliver something that can be easily used by MicroProfile developers. So the whole idea is we're speaking the same language. So Red Hat and Microsoft, we could build a microservice for our back-end services that allows you to just access them. Right now, we have APIs and SDKs, and we're developing MicroProfile profiles, if you will, that allow you to actually connect our services directly. So you could just say, oh, here's a MicroProfile. This is what you can expect to get from this service, and be able to just run that service on the back end using your Java app that you already have. So,
and all these APIs are very easy to use. They're all CDI enabled, so you can use annotations. And James is going to show you that in a minute. We have config. It's about externalizing the configuration of your microservices. Fault tolerance covers concepts of bulkhead timeouts, retries, circuit breakers. JWT is all about authentication and authorization for microservices. Open tracing, in a highly distributed environment, you know how difficult it is to trace how a message traverses the architecture. Open tracing allows you to do that easily. Metrics, health check, it's an API that allows basically the microservice to talk to the underlying infrastructure to let it know whether it's up or down. REST client, if you want to quickly enable a REST API to any microservice, with a simple annotation, you accomplish that. And OpenAPI, if you heard of Swagger and OpenAPI, that API, excuse the redundancy, handles all that for microservices.
Yeah, one thing I want to add from the developer perspective, the way that Spring enjoyed so much popularity was it was an alternative, an easier to use alternative to Java EE, over 10 years ago. And Spring Boot has provided this opinionated configuration capabilities. The Spring APIs are very easy to use. In the same way that Spring enjoyed that popularity, MicroProfile is looking to simplify that even more. So for example, if you want to do a circuit breaker with Spring, you import Hystrix and you write a lot of code, and you have a fallback, and you configure retries and things like that. MicroProfile makes that even easier through kind of simple annotations. You have to do a very minimal amount of work, both not only for fault tolerance, but for all of the APIs. So the idea is not to get into the same heavyweight trap that Java EE suffered from in the past with huge XML configuration files and lots of weird other config files that you need to set up. So it's super easy to use, and I'll show you that in the demo in a couple minutes.
So just quickly, what's coming up next as far as the MicroProfile project? 2.1, release 2.1 is coming out in a week's time, pretty much. That's going to include Open Tracing 1.2. It's going to update the JOT API, which is the Authentication and Authorization Library. There's going to be a patch release included there. No, actually, I'm sorry. That's going to be a patch release separate from the umbrella release, MicroProfile 2.1, but it's going to come out at the same time. And also, there's going to be a standalone reactive streams operators project that is going to be released on that day. There's also an IT decision maker C-level white paper coming up soon. There's a technical white paper coming out soon that is going to be available. These things are going to be available all from microprofile.io. There's also a start microprofile.io. If you're familiar with Spring Start, we're going to have something.
Initializer.
Yeah, the initializer. Yeah. And also, we're going to have we're going to add more samples, code samples for developers to leverage. And besides the APIs, the sub-projects, the APIs that I mentioned before, there are outstanding topics that the community are talking about. And some of these are long-running actions, which is basically transactions, reactive streams, reactive events, data access, and event data, as well as there's a service mesh subgroup that is having all these groups, the API subgroups or sub-projects, as well as these other topics. They have scheduled meetings on a weekly or bi-weekly basis. Please, if you're interested, everyone and anyone is invited to join any of these meetings. There's a calendar for MicroProfile project available. It's public, and you can go check it out and just dial in the information, the number, and join the call. So now I'm going to pass it to James.
Okay, so I'm going to talk a bit about Red Hat's implementation of MicroProfile. So the project is called Thorntail, the product is called Thorntail, and essentially the primary purpose of Thorntail is to provide a path forward for enterprise Java developers looking to do microservices and reuse their same existing knowledge, both from Java EE and other frameworks that they may have used in the past. It's an open standard, standard in quotes, because it borrows some of the implementation from Java EE to implement the base MicroProfile APIs that you saw. But again, it has a microservices focus, so minimal set of standards. The difference between Thorntail and other implementations, the difference between all of the implementations is the way in which you build and deploy applications. So for the Thorntail perspective, we support both the uberjar or fatjar approach, which is common in the Spring Boot world. You build a jar file and you run it with java-jar jar file. We also have support for building pre-configured, essentially mini app servers that you can deploy in the traditional way. So you build an app server container image, you run that, and then you use that as your base container image to build another container which contains the application. The benefit there is the layering in the container images allow you to, when you make changes, right, you only push the topmost layer that changes. You don't have to push the big app server piece, which it's not big anymore through Thorntail. It only brings in the components that you need, whether they're MicroProfile components or other components of Thorntail that you may need. So for example, transactions or database support, things like that. So again, you're basically just building a small, lightweight, fat jar that you can then put into your container system, whether you're using Docker directly or Kubernetes, or hopefully Red Hat's distribution of Kubernetes called OpenShift, which I'll demonstrate in a minute. So from the Java developer perspective, the way that you use pretty much all of the implementations is through your build configuration. So in this case, I'm showing an example of a Maven pom.xml snippet. This is where you bring in the microprofile dependencies for Thorntail. In fact, it's where you bring in the Thorntail dependencies. So you simply declare a dependency on a BOM or bill of materials, and then that will define all of the components in Thorntail, many of which are from the microprofile world. And then you can go and add your dependencies as needed. Or Thorntail has an interesting feature where it will detect what your code is using. So it will look for certain API signatures to see if you're using JPA or CDI or JAX-RS or RESTful interfaces, and it will automatically bring those in. So this is a really great way to move your existing applications to the cloud by doing this auto detection. You don't have to figure out what you need. It will find the minimal dependencies for you by doing essentially looking for these API signatures through language features and essentially decompilation and looking at the things you're using. So a couple of examples of how you would use this from a Java developer's perspective. So the simplest examples there's two here. So for externalized configuration, for microservices, you don't want to hard code IP addresses or database URIs or anything else of that nature, because you want to be able to take these immutable containers that you're building your microservices with and move them to different environments where you have staging and production and testing databases, and a developer desktop might have a different configuration. So for microprofile, it's a simple annotation. You give it a property name. If you're a Spring developer, it should be very familiar to you. Spring Boot has a order of precedence where it looks for properties, whether in your application.properties or application default properties or some specific profile you happen to be using. Exactly the same here. It looks for properties, Java properties. It looks for environment variables. And then you can also plug in your own implementation to look at configuration values from other places like Spring Cloud configuration or Spring Cloud Kubernetes. So very simple way to externalize configuration. Health probes, also very simple. You declare one endpoint. You can define one or more health checks. These are used by systems like Kubernetes to determine whether an application is up or whether it's failed and to stop routing traffic to it. So to do that with microprofile, it's a very simple annotation. You provide an implementation of that health check. That health check can do whatever you want it to do. And then it will return success or fail, and then the system that's managing those microservices can behave accordingly. A couple other examples for doing metrics, so things like if you're using Prometheus to capture metrics for your application, you can add this counted annotation, so you can track how many times a particular method is called or things of that nature. For fault tolerance, we have as I mentioned earlier, a very simple annotation for declaring a particular method should be protected by a circuit breaker, so that if that method call takes too long or times out, it does some retries, and if that then fails, then it can fall back to an existing implementation. So very simple APIs designed for Java developers who don't want the complexity of what we've had with a number of frameworks over the years. So how does this all relate to Azure? We're at a Microsoft conference. We're talking about containers in Java. So Brian, you want to give some information about the connection between Azure and the rest of the microservices world?
Right, yeah, so we talked a little bit about microprofile and what the advantages of using that versus just building your own microservices from scratch with the way you want. If you basically keep with those three base classes, those base packages, you can interact with other microprofile applications. Same goes for data and data services or cloud services that we have. Using the Open Service Broker, we're part of the Open Service Broker API initiative and at Microsoft, and we actually are participating in that because it makes it easy for us to expose our services to applications out there. One thing I should mention, at Microsoft, we're at heart a dev company. We're built on code. Our senior managers all write code and stuff. And so the idea here is that we allow you to preserve your investments. through code. And one of the ways we do that is Open Service Broker for Azure, allowing you to just basically grab our services and find out quickly what kind of interactions you can have with them and plug it into your application. So, for example, for Cosmos DB, which is a multi-model database that has NoSQL, tables, Redis-like sort of key-value pair functionality, and a bunch of other things built in, you can just take the Open Service Broker for Cosmos DB and plug that into your applications and run Cosmos DB on the back end without having to know a lot about it. Or if you have a partner that you want to share your application with, they can use the OSB API to actually access your instance of Open Service Broker. It's actually something we did building the demos that James is going to show you. I built a Cosmos DB application on the back end, and then we have Open Service Broker that actually accesses that Cosmos DB, not application, a service. It actually accesses that Cosmos DB service in the front end. But it's just a way to actually manage and share things. Is anyone here familiar with Helm? How many people are familiar with Helm? Okay, a couple of people. So it's something that was born out of Kubernetes. Anybody who's tried to build, how many people have tried to build a Kubernetes manifest before from scratch? Nobody, okay. Something like Helm, if you ever try it, it's harder than you think. It's actually really easy to use tools called Draft and Helm to build these Kubernetes manifests and automate the whole process. And we bought a company called Deus a couple of years ago that actually is the corporate custodian of Helm and Draft and a few other tools for Kubernetes. So basically, because it's Kubernetes-based, you can also use it with Open Service Broker and platforms like OpenShift.
Cool, so enough talking. We're going to show you the demo now. So what we're going to do with this demo is we're going to show you how to connect an application to Azure services through the Open Service Broker running on Kubernetes. So let's switch over to my laptop here. So we're going to start with a basic Java application. So we'll start where we're all familiar with. This is a very simple RESTful application with a GUI front end to it. There's a couple of RESTful endpoints. This is a game. It has a scoreboard. That scoreboard is backed by a database. I have two implementations for my database backing. I have one based on JPA that we should all be familiar with. It's very simple. It has has a get scoreboard with a select statement. It has an add score, and it has a clear all the scores. So a very simple RESTful API. I also have an implementation for Cosmos database using the MongoDB API. This is also extremely simple. It's a couple additional lines for doing for caching the collection and database handles, but also very simple. So let's go ahead and run this. With Thorntail, did you want to say something?
I just want to jump in. If anyone hasn't seen this before, this is actual Visual Studio Code. It's a free open source text editor, and you can use it for doing basic Java editing, just like James is doing.
Yeah, so I'll zoom in a bit. So I'm just going to run a basic command line. I'm going to do java-jar. We should all be familiar with this. This is essentially running a fat jar that was created with Thorntail. Thorntail was able to detect all the APIs I needed and bring them in, and so I can essentially just run this locally, running directly here on my laptop. So now it's up and running. I should be able to, in my browser, I should be able to access localhost 8080 and test this out as a developer. Very easy. You guys should be familiar with this particular game. Yeah, Microsoft conference, I thought it'd be interesting to use a game we all know and love, so Microsweeper. So as I play, and I fail, obviously, because I'm terrible at it, the scoreboard here on the far right, which you can see, gets updated with the name. I can start over, I can play again. All this is going to my JPA, to my database. It's actually an internal H2 database that I'm using in memory. So our job as a developer is to now, we want to hook this up to our Azure services using MicroProfile to export to expose and take advantage of the MicroProfile APIs to make our application work better and to link it to Azure services. So let me zoom back out here. So let's go over and check this out. So I've already deployed our Kubernetes environment, which is Red Hat OpenShift. That's our Kubernetes distribution. I've already deployed this to Azure. If you want to do this yourself, OpenShift is in the catalog, so If you search OpenShift in the catalog, you'll see a link here, the Red Hat OpenShift container platform. You click on it, you click create, and then there's a couple of steps. You step through a wizard to enter your resource groups and your access principal credentials and a couple of other things. And it will create this OpenShift environment for you with the Azure Open Service Broker already installed that Brian talked about earlier. So I've already done that. So I have my system here. If I head over to my dashboard, you can see a number of components here deployed for OpenShift, including my Cosmos database, which I could deploy through the OpenShift. I'll show you how it works through the Open Service Broker, but it takes 4 or 5 minutes to deploy that and get it up and running. So I've actually already deployed it. So let me stop this and go back to my OpenShift console. So this is OpenShift. This is our container orchestration. It essentially just runs containers on different nodes in your cluster. I've deployed the application here. I've also deployed Jenkins, so we're going to use that for some CI/CD pipelines that we'll be running in a moment. But if I click on this link here, you can see the same exact application is running on OpenShift, running again on Azure, and it's again still using that internal database. So our job is going to be to convert that over to use MicroProfile. So let's do that right now. So I'm going to close the terminal. So what we're going to do as a Java developer, you should all be familiar with pom.xml files. In order to use MicroProfile with any of the implementations, you simply need to either have, if the implementation has a feature to auto-detect, you can use that. Otherwise, you can manually declare which APIs you need. So in this case, we're going to do health check and externalized configuration. So I'm going to copy from my cheat sheet here and insert this into my pom.xml. There are plugins for different IDEs that will automatically add these for you, but it's essentially nothing more than just adding a couple of lines to your pom.xml. So I've added those for health and config. So what that allows me to do now is to use those annotations that I showed earlier in the examples. So for example, if I want to add a health check, I'll simply, to my JAX-RS application, I'll add a health annotation. I want to implement one method, so I'll implement a health check here. And then it's saying that I need to implement an actual method here because I implement an interface. So I'll add that single method. So there's a single method called call. Let me zoom in on that. So this is the method that will implement my health check. I can do, as I mentioned, whatever I want here. I'm just going to do a very simple response. So I'll call it basic check. Again, you can do like multiple of these. So I'll just do basic check. I'll say declare that it's up. And then I will build that since this is a factory API. And that's it. So that's my simple health check. I'm just basically saying once this application is up and running, this is going to start returning true. It's going to expose a health check API at /health. And any system, whether it's Kubernetes or anything else, can then use that health check endpoint to figure out when the application is healthy. So with a couple of lines, I was able to add that health check. No fancy XML editing, no weird configuration, and so forth. So the second one is the configuration API, and this is where we link up to Cosmos database. So before I do that, I want to show you how you actually deploy Cosmos database in Kubernetes and OpenShift. So here on the OpenShift main console, you have this catalog. This is the service catalog. It exposes all of those things that are available through the service API. So if I type Azure here, you'll see there's a number of services that I can deploy into my applications using the service broker. So for example, for the MongoDB API for Cosmos. So you click here, you can be presented with a number of different plans. So you might have like a free tier and a silver tier and a gold tier. In this case, as the first implementation of this, there's only one tier. So you click next. You can then declare which Kubernetes namespace to deploy this to. Namespaces in Kubernetes just allow you to separate different pieces of an application from developers, between developers or between project teams. So you declare a project name. I'll use demo here, which is the project I'm using. Then you can configure configure Cosmos using the Cosmos configuration options that are exposed through the Open Service Broker API. So that Open Service Broker API is where you declare what can be configured in a service. And then the user, in this case me, can configure those values here. Then I step through, there's one more screen to do a binding, which I've already done. A binding allows you to expose the credentials created by this service broker to your applications so that you can then integrate with them from the application itself. So I won't do that. As I said, it takes about 4 or 5 minutes to do that. So once you click go, and 4 or 5 minutes later, you'll get this thing called a provisioned service, which you can see here in the screen. So this is the Cosmos database Open Service Broker deployment into my project. If I click on it here, I'll see the configuration values that I had supplied. There's also a set of bindings that I mentioned earlier. So this is what binds it to the application. So these bindings are exactly what you think they are. They are the connection string, the host, the password for the database. Please don't copy this and start running Bitcoin mining. But the port number, the URI, the username, all these things that you need to put into your application. And the way you put them into your application is important, right? You don't want to hard code this string because you might have multiple databases, one for production, one for staging. So this binding allows you to do that dynamically. In Kubernetes, again, our container orchestration platform, there's a couple of different ways to do that. The most basic is called a secret. And a secret allows you to essentially, when your application runs, it will see a file on the file system that it can load, just like a Spring Boot configuration file. That file can contain secrets like database usernames and passwords. The way those are transmitted to the running application is through cryptography. So you can, through a secret, be assured that your passwords are not sent over clear text over the network, even inside of your internal network. It's all encrypted. So then once it gets over to the application, you can expose it. You can either mount that or read that file, or you can look at it through environment variables. So for simplicity, I'm going to use an environment variable. So what I've done here is I'm going to go ahead and bind this to my application called MicroSweeper. This is the application, the Minesweeper application that's running. So let me go ahead and bind that. So there's a button here called Add to Application. So if I click that, I can choose my MicroSweeper application to add it to. Again, I can either do it as a volume where it mounts it, or I can do it as an environment variable with a prefix. So environment variables are then created and available to the application using this prefix. So go ahead and save that. So now if then next time my application is deployed, it will see these environment variables. The other thing I need to do is shift from using my H2 database in my application to using the Cosmos DB. So I will go ahead and make that change. So that change is in what's called a deployment config. This is a way in how to deploy applications in Kubernetes. So there's an environment settings here. You can see the secrets from Cosmos are already there. I have this value here set to development. I'll set it to production. And I'll go ahead and save that. Now I'm ready to redeploy my application so that it can take advantage of that stuff. Because as you remember, the application is still running with the old H2 database. So back here, let's change our Cosmos implementation to use this new URI. So right here, we have a hard-coded URI. We're going to comment that out. We're going to inject through CDI, which is also part of MicroProfile, a config property, which is right here. We'll give it a name, is scoresdb_URI. And then it's a private string URI. So what's going to happen is when this application runs, MicroProfile and Thorntail are going to inject that config property by looking either in the system properties or in the environment variables. It will find it in the environment variable, set this value URI to that value, and then my connect string down here will then use it to connect to Mongo database. So that's it. So I have my health check defined. I have my config property defined. And so now I'm ready to push this to my source code repository because as a developer, I've made this change and I'm ready to get it tested and put into production. So I'll switch over to my Git repository here and I'll just go ahead and commit. Actually, you know what? Yeah, let's just go ahead and commit this. Commit all, and I'll say add Mongo or add Cosmos DB support, and then we'll go ahead and push that to our Git repository. So go ahead and push. And once it pushes, a webhook will notice that push, send a message to our infrastructure to say, go ahead and rebuild this application, retest it. So if I shift over to our build pipelines, you can see a new pipeline was just kicked off here. It's going to take about 4 or 5 minutes to rebuild the application using that new code. It should then pick up those environment variables, connect to Cosmos DB on Azure, and then off we go, and we'll be able to use the scoreboard will then be backed by a replicated worldwide database through Cosmos database. So while that runs, I'll stop and ask if you guys have any questions so far. Yes, in the back. Yeah, so that's a good question. So the question was, how did you figure out that /health thing? So that is the default /health. That will expose a health check endpoint onto your application, in your application. Whether something takes advantage of that or not is up to the thing that's orchestrating your containers. So one thing that I forgot to do here is actually tell Kubernetes about this health check endpoint. Because right now, it doesn't know about this health check endpoint. So the way that you tell Kubernetes about that is either through, we could do it through the GUI, but I just have a simple command line here, which will set what's called a probe, a health probe. So let me run that, and that will set up a health probe for my microsweeper application. So then, at this point, Kubernetes knows about /health. That, again, is the default in MicroProfile. You can configure that to be whatever you want. But now that I've set that, while that's running, if I go and look at the application's deployment configuration, we'll see that it's now has a health check. So if I go to edit health checks, you can see there's basically every I think I set it to, it doesn't show it here, but let's see, where's the period second? So every 15 seconds, it's going to make a REST API call. It's actually just going to do HTTP, not even REST, to /health and do an HTTP GET. If that succeeds, then the application will be considered up and healthy. If it fails, then it will fail, and the application will stop getting traffic. So that is the way that you link an application's health endpoint to the orchestration platform you happen to be using, whether that's OpenShift or Cloud Foundry or Heroku or whatever you happen to be using. That's that final linkage. Does that answer your question? Okay, perfect. So this should be done in another 1 minute or so. And so once this comes up, we should be able to see the application up and running and using Cosmos DB on the back end. So we'll wait for that. Any other questions? Yes. Yeah, so that's a good question. So Pivotal is not a member of MicroProfile, right? They are Jakarta EE members, though.
Right. So are you guys familiar with Jakarta EE? Okay. So Pivotal is a member of Jakarta EE, but not a member of MicroProfile. So that's their current position.
Yeah. So in some respects, it is a bit of a competition. You can build, microservices with Spring Boot. You build microservices with Thorntail. You can build with any of the other implementations. You can build microservices with WebSphere Liberty or JBoss EAP or Wildfly. So yeah, it's a matter of choice, which is really, really good for our community. Yeah.
I'll just add from the Microsoft perspective. We support OpenShift. We're participating in the projects, including MicroProfile. We also support container-based applications such as Pivotals and just basic Kubernetes as well. So we have basically support for whatever you want to run. As I mentioned before, it's all about preserving investments. So if you're investing in something, we want to make it run. So we're trying to be a general platform for that as well.
Yep.
Yeah. And one more comment to add to that is we have an offering that includes a set of runtimes. And among those runtimes, you'll find Spring Boot, Node, EAP, Thorntail.
Eclipse Vertex for doing reactive
Vertex for reactive,
systems.
yeah.
One other thing you might not know about Azure as well is we do actually implement WebSphere Liberty and other tools that you might not be expecting to see on a Microsoft platform, but we do actually have them. We have a large Linux base. I guess you guys probably already know that I guess 40% of our VMs are Linux. So we're supporting all operating systems and also most of the platforms that OpenShift runs on.
You may notice this is taking a bit longer than the previous run, which was 21 seconds to deploy. The reason that is because of that we added that health check. So now OpenShift is able to see that the application is either up and running or not. So we'll go and take a look and see if it's coming up here. Yeah, so it's trying to shut down the previous version of the application and bring up the new one. So that should hopefully be done momentarily. We will see. I'll just go ahead and kill this while I'm at it. So let's see if this is going to work here. Not sure what's going on here. Is that coming up to 0? Microsweeper number 10, 1. Let's see if I can force it to come up. It's set to 0 for some odd reason here. Go ahead and edit the YAML and just change the replicas. Yeah, I'm not sure how that got set to 0 to 1 or 0. Awesome. Oh, that's under the status. Yeah, I'm not sure what's going on here, to be honest. Okay. Well, the demo gods have failed me today. So this one will come back up here momentarily, and we can kick it off again. But essentially, what would happen is that code that you saw would pick up that environment variable, connect back to Azure. And then, for example, in the Cosmos database instance running on Azure, I would be able to see. In fact, I'll probably see the collection from the previous run, where you have these scoreboards set up and setting their value into Azure. So if I can do this and hit execute query, you'll be able to see the data coming up there. So there's the data from our previous run of the demo, where the scoreboard is then backed by Cosmos database. Connected and linked up through the Open Service Broker API, and then exposed in the application using microprofile. So I'll kick this off again. We'll see if it completes, and then Brian, you can take over. And yeah, so that failed again. So I'll just go ahead and start it again, and we'll switch back to the slides. And if this works at the end, we can.
We showed at the end.
Yeah. Okay.
I think that was essentially it. We've got the next steps, basically, which is to check out MicroProfile. We've got some projects going on. Did you want to show the calendar, Cesar? You got
Oh, you mean the calendar? Yeah, you can just click on that. So as I mentioned before, all the sub-projects have recurrent meetings, weekly meetings. And there's every other Tuesday also there's a community hangout, and everyone's welcome to join. So if you want to learn more about MicroProfile, please just go to the calendar. If you go to that calendar, you'll see all the events related to MicroProfile, all the sub-project meeting times and dates, the hangout calls. There's also a marketing call every other week on a Monday. And if you're interested in config, or if you're interested in fault tolerance, you're more than welcome to join that specific call by checking the calendar.
Yeah, by the way, I just determined exactly what happened here. I actually ran out of disk space.
Oh, no.
So I think my default it was 20 gigabytes.
I couldn't get it.
If you look here, you can see this. Oh, it actually did come up finally. But it did run out of disk space earlier here. Node under disk pressure. So this is Kubernetes detecting that I had not enough disk space left on my node, which is something I probably should have checked ahead of time, but I didn't. And then as it started to clean up itself from previous runs, it then was able to deploy the application here. So now it's up and running. Yeah.
Okay.
So, anyways, sorry about that. Check your disk space before you deploy to production, I guess, or have a big enough disk. So yeah. So you switch back.
Yeah, we've got a 6 here.
Okay.
So here's the actual MicroProfile calendar. If it was the weekly meetings, so you want to talk about the weekly meetings, right? Or the monthly meetings.
Right, so every other Tuesdays.
Yeah.
Every other Tuesday there is a community hangout, like on the 18th there is one. There you go.
Yeah. The reactive hangout.
Yeah. And every entry will have, the bridge information to join is free, and also the minutes, the file to the minutes. So if you want to read up on what's been happening for each of the sub-projects, you can read, through the minutes document.
That's it. So don't forget your evaluations. Also, yeah, we've got about a minute for questions. So, and we'll be around after as well. So any more questions? Please do remember to follow us on Twitter. And
we have some stickers here. If you like stickers and hats,
oh, yeah,
Red Hat Microsoft hat.
Thank you for hanging out. And like I say, thanks for coming today. But yeah, we have a lot of, a bunch of hats and stickers too. And questions? Anything else?
Very good.
All right, guys. Well, thanks. Have a good rest of the show. And
yeah, thanks for coming. I'll take the hats over there by the door, so
thanks.
you can't escape.